everyone. So we have solved two questions of this interview series, and we are going to solve the third one, which is remove duplicates from sorted array. It is a question which is similar to the second question which we solved previously, the remove element, in which we have been given a value and we have to remove that element. But in this question, we have to remove all the duplicates elements, and we have to also maintain the relative order, which is given here, relative order. And in the previous question, there was no constraint of maintaining relative order. So in this question, what we have to do is that we have to replace in the duplicate in place, means we have to return all the unique elements from the starting. Like you can see in the example that we have to remove here 1 and replace it with 2. This is kind of similar to the first question that we solved. So what we can do is that we can similarly approach this question. What we did in first question was we did use two pointers, and we moved one pointer with the unique elements, second pointer with the duplicate elements, and we skip the duplicate elements. So the same thing we are going to do it here. Okay, and okay, so let us move to the diagram so that we can understand better. Okay, so how we are going to solve this problem? So first intuition will be that we will check if it element exists in the array. If it is not, then replace it with the unique element, because we have to replace it in place and we can't just remove it from here because it will cause time complexity of O of n first case. So we have to replace it with something. And what we can do is that we can replace it with the unique element so that we can return the array with all the unique elements. So what we are going to do is that we will point this I and j towards the I single pointer. Okay. Now what we will do, we will check if this element exists or not in the set. Let us use the first intuition will be use the set, because how we are going to check if it element exists or not. So we are going to use unordered set. So this is our set. So what we are going to do is that we are going to replace the jth element in the position of I. So let us see this condition. What we are going to do is that we will nums of I, nums of j. We will equate this thing. Why? Because we want the unique elements at ith position, and we are checking it by incrementing j pointer. So if the element at j doesn't exist in the set, it means it is a unique element, and we will replace it in the position of I. So let us move the j pointer. J will start from I and j will be initially 0. Okay. Now j is pointing towards 0. 0 exists? No. Replace I with j. Same. 0 will be replaced by 0. Nothing changes. What we'll do is that we will increment the I and j pointer both. Understand, we are going to increment I and j pointer both. Okay, so we have incremented I and j, and we have also inserted 0 in the set. Okay, so we have also incremented I and j and put it into set. So I and j are at 1. Now we will check if 0 exists. If it exists, then we will continue incrementing the j pointer. We will not do anything with I pointer. Now check if point element of j exists in set. No, because 1 is not present in the set. Now what we will do is that we will use this condition. We will implement this condition. Nums of I is equals to nums of j. So we will replace the element at I with element at j. We will keep element j as it is. We will not change anything with the j element. And what we will do is that we will also insert it in the set so that we can trace it if it exists in the array itself or not. Now what we will do, we will again improve increment j, and we will increment I also. Okay, so we are here. Again, 1 exists. Yes, it exists. Move j. J exists. Again increment. J exists? No, because 2 is not present in the set. Now what we will do is, again this condition is there. We will implement this condition. I will replace the element at the position I with the element of position j. Okay, so we are here. What we will do is that we will insert the element 2 in the set. Again, increment I and j. Check the condition. 2 already exists in the set. No need to do anything. Again, increment the j. 3 exists. No. Again, replace the 1 with 3. Okay. Increment I pointer after that. And also j pointer. 3 exists. We forgot to add 3. So yes, 3 exists. Yes, 3 exists. Again, increment it. 4 exists. No, 4 not exist. So what we will do is that replace 4 here. Okay. J is at the last element, increment it. So j crosses the length of the array. We will stop it here. Okay, so we got what we wanted. What we wanted is that unique element at the starting of the array. We don't care what the elements after that comes. What we wanted is 0, 1, 2, 3, 4. This element only we wanted. This is the output that we want. This is we got. Okay, so this is the solution. And we have used 2 pointers. So the time complexity of this solution will be O of n, because we are effectively moving j from 0 to n. So the worst case can be go up to n. So time complexity will be O of n. Let us talk about the space complexity, because it is important here. Space complexity, what is space complexity? What's the worst case it can store? It can store all the elements, because all the elements can be unique. So in the worst case, it can also go to O of n. So time complexity is O of n. Space complexity is also O of n. Now we have solved the question in O of n and O of n space complexity. Now we will understand the important point that is given in the question, which is it is a non-decreasing order, which means that it is efficiently increasing. The array is sorted. So we can optimize this point. You are understanding? We can optimize this point. This point will be there because we cannot reduce this time complexity. The time complexity will be O of n only. But what we can do is that we can reduce this space complexity by this condition, increasing non-decreasing order. This is general case. It will be applicable if it is not sorted. But so this is we will be having 2 pointers like the approach before. Now we will check this condition. This condition. So j is at pointing at 1. We check this condition, nums of I is not equals to nums of j. So the element is equal. So what we will do is that we will increment the j pointer. J is here. We got this condition here. Now j is pointing at 1. So it is not equals to I. Now what we are going to do is that we will increment the I pointer. So this is something like if this, then we are going to increment the I pointer. Now what we are going to do is that we will replace the ith element with jth element. Why we are doing that? Why we are using this condition? We are using this condition because the element pointing at I is not unique element. It was pointing at 0 first. Now it will again pointing at 0. I mean, it is not unique element. So we have to replace it with the unique element, which is the j, because we seen that the element at j is not present in the array, and we can say it because this is important. Why we can say it? Because this is a sorted array and we cannot get 0 after 1. So this is why we have not used the set. This is the condition. So we cannot use this approach while the array is not sorted. So this is important. So this we will replace it. The I is pointing at 1. So we will replace the 0 with 1. J is here. Again, we are going to check. We will increment J as the loop iterates. Check I pointing at J. Element equals no. Element not equals again increment J. Not equals again increment J. Now we can see that we have got the unique element, which is not equals to the number pointing at I. 1 is not equals to 2. Now what we are going to do, we are again use this condition. Okay, so we will increment the I, as we can see in the pseudocode. Increment the I. We will replace the ith element with the element with J. The J is present here. Here. Okay. So J is present here. Now the same approach, again increment J. 2 is present at I. Yes, 2 is present at I. Again increment 3. The 3 is present at I? No, because the element present at ith index is 2. Again, we will replace it. Again, we will increment 3, so on. So we will get here 4. And J is over. So the loop is over. So the approach here was similar kind, but we did not use the set. Why? Because the array is sorted and we cannot get 0 and 1 again after having 2. So this is the important thing. The array is sorted and we cannot get the repeated elements after it got exhausted. We got 0 here, we cannot get 0 here also because it is sorted. So once the 1 is done, we cannot get 1. So this is the approach. The same time complexity will be O of n, the same which we did it in last solution. The space complexity here will be O of 1. So this was the improvement that we did from last solution, the space complexity. So that is how we are going to optimize this, and we will see the code. Okay. Okay. So the code is very simple for this solution. We will determine the size of this array. If n is equals to 0 or n is equals to 1, because if its single element is present and we don't have any duplicates, return n. Okay. Now we have two pointers, I is equals to pointing at 0 and j pointing at 1. So let us use the for loop. J is equals to 1, j is less than n, j plus plus. So we will iterate the j pointer. What's the condition we were checking? This is the condition. So let us see. If nums of j is not equals to nums of I, what we are going to do? We will increment the I pointer. Now we will replace the element at I with j. Hit j. So j will be incremented by the loop. I we are incrementing here. Now we will return what we should return. So ith element will be pointing at the last unique element. Ith element will be pointing at last unique element, which is 4. I think we haven't changed it at last. Okay, so ith element will be pointing at there. We have to return the size of array. So I will be 3 and the size will be I plus 1, that is 4. So we have to return I plus 1. That it should be our solution. We are going to run that. Let us see what is the solution. We got it. Submit it. Same, we will see the time complexity. Time complexity is often. So that's it for today's question. We will again solve the next question in the next video. Thank you.